Now let's create a folder called Logic that can provide some similar operations, but will interact with the model classes. This is where we can add validation, business rules, and other logic if we want. I'll start by creating a file for an interface again, called iProductLogic.cs. I'll add a namespace, then a public declaration for the interface, and then I'll paste in the method signatures. Note that this interface is using the product model class instead of the product class, but it's still primarily serving basic CRUD operations. The main difference is that we're referring to classes that our controllers can use. Now I'll create a file called ProductLogic.cs that can contain the implementation class for this interface. This time I'll paste in all of the content for the class. Note here at the top, the constructor is taking an iCarvedRock repository from the DI container and setting it to a private field called _repo. The getAllProducts method gets the products from the repo with the getAllProducts async method we just set up. Then it uses a link projection to turn the product objects returned into a list of product models. I haven't defined this FromProduct method yet, and we'll see that in just a sec. But this link select here is just a simpler way of writing the code that I have commented out below. The remaining methods are doing pretty much the same thing, providing a simple wrapper for the repository methods and converting the product models objects to products and vice versa where needed. You might wonder if such a layer is really needed, and once again it comes down to any complexity with your business or use case. We'll see soon some logic that gets added here, and that'll help clarify this concept if things are a little unclear at the moment. But now let's add those conversion methods. I'll go over to our product model class, and I'll paste in some code for those methods at the bottom of the class. It's got a static FromProduct method. The static keyword here just means we don't need an instance of a product model to invoke this method. And it'll take a product object as an arg and return a product model. ToProduct can operate on an instance of a product model and return a product object from it. You may be scratching your head a bit about this code. Shouldn't this be in the product logic class? Or couldn't we use some kind of mapping routine? The answer to both is sure, maybe. But I put these methods here to keep things a little on the simpler side for now. There are different approaches you can take for refactoring the scaffolded code. Just keep separation of concern and long-term maintainability and flexibility in mind. Now our product logic class is happy with those conversion methods in place. Now that we've got both repository and logic classes in place, let's update the controller that we started with to use them. First off, we should update the constructor here to inject an iProductLogic instance. Then we can create and assign a private field for it, and I'll update it to use that underscore prefix convention we mentioned earlier. We won't need this hard-coded list of products anymore, so I'll comment out this assignment in the constructor and the property on the class, and then do the same to this method that returned them. Now let's fix the index and details methods. In the index method, I'll set a local variable for products to be the await result from the logic's getAllProducts method. Since this is an async call, I'll update the method signature to specify async and then return a task of iActionResult as well. Then I'll update the return statement to use this local variable instead of the class property we just commented out. For the details method, I'll use the getByProductID method. Our refactoring created those two new services, the repository and logic classes, that we're wanting to be included in the dependency injection container. So our last step here is making sure that we get them registered. Over in program.cs, we can make the necessary additions. Right after we add the product context to the service container, we can call builder.services.addScoped, and we'll register an iCarvedRock repository in the container and use the implementation of CarvedRock repository to resolve it. And we'll do the same thing for an iProductLogic instance, using the product logic implementation to resolve that. Now let's run it and see if those two updated controller methods work. Here's the app again, and I'll click the products link this time to see our original controller, and the listing works just fine. This is great. It's using our two new services and everything is showing up correctly. Now I'll hit the details link for the first item, and we get an error. It's saying that it wasn't expecting a task of iActionResult, but that's what it got. Let's go have a look at the code. Here's our details method, and sure enough, the getByProductID method from our logic is an async method, and I forgot to add that to this controller method. Let's return a task of iAction result, await the getByProductID call, and then add the async keyword to the method. Now let's try it again. Here's the app and the products link, still working fine, and now we'll try the details again, and this time it works. So our existing logic has been refactored to use the database and the new services we created. In the next clip, let's get the create, edit, and delete methods added here. Let's finish up the scaffolding refactor by getting create, edit, and delete methods added to our original controller and views. We can take the views from the scaffolded products.db folder, and I'll copy the create, delete, and edit ones. Then I'll paste them into the products view folder. We should be working with product models in these views, so we need to update the generated code to refer to this product model class as its model. The property names are the same, so this is the only change we need to make here. And I'll change the delete view as well, and then do the same thing to the edit view. Our index view didn't include any kind of link to create a new product, so I'll add one here for that. I've pasted in an A tag with the ASP action helper that refers to the create action. Now back in the controller, I'll paste in the methods that we'll use. Once again, these are going to look similar to the scaffolded code, but they'll use our logic class to do the real work. The code here should just take some input, invoke some logic, and get the user to the view we want when it's done. Create just returns a view that'll contain the form for data entry. Then the post method binds input, checks model state, and invokes logic. We'll talk more about model state and validation in the next clip and the modules to come. Edit works in a similar fashion, always using the product logic to do the real work relative to any products. And delete is the same way. Let's try all this out. Here's the app, and I'll go into our custom products page. The listing is still fine, and I'll edit the first product. The page comes up, and I'll provide some new text in the description and save it. That works, and the edit shows up in the listing. Now I'll delete the Woodsman product. The page comes up, and I'll press that dangerous looking red button. That works too, and Woodsman is not showing up in the list anymore. Our new Create New link is there, so I'll try that now. The empty form comes up, and I'll provide some values, then hit Create. That worked too, so our refactored scaffolding now works for all of the basic CRUD operations. Let's look at some very simple validation in the next clip to round things out here. Now let's talk a little bit about simple validation. Here's the post method for the edit action. One of the lines here is the conditional that evaluates modelState.isValid. This is a property on the controller that'll validate the model being passed in. If the model state isn't valid, then the view with the passed product will be displayed again, and the model state property will have the errors. If we take a quick look again at the edit view, it has those spans of ASP validation for helpers with the names of the properties. Those are going to display the errors from the model. And by the way, the create view has these same ASP validation for spans. The easiest way to wire up some rules about these properties is with attributes on our model class called data annotations. Here's the product model class, and the simplest one is just called required. Any guesses what that does? These brackets around the text are what marks this as an attribute, and it applies to the property underneath it. So I've just marked the name property as a required field on the model. To resolve this red squiggly, we can use the light bulb and add the using statement for system.componentModel.dataAnnotations. Another thing that you can do with these data annotation attributes is set the display name for a field. I'll do that here and set it to product name in all caps, just so you can see clearly how it gets set. That requires another using statement, and now that's in place too. I'll make the description field required, and then we'll get a little fancier on the price field. I'll paste in the attribute code. The first line says we want a currency here, and the second is a validation that specifies a range for the price that someone can enter. Anywhere from 1 cent to $1,000 is what we'll allow. And then I've got a custom error message to use if the validation fails. The curly brace replacements will be the property name for item 0, and the low and high range values for items 1 and 2 respectively. The :C in the curly says to format those values as currency in the string. With no other code changes than these attributes in place, let's run the app again and try adding a new product with these attributes. Here's the app, then the listing, and the Create New page. I'll just click Save without any data, and you can see how the all caps product name now came into play here. And the error messages are telling us that we have some required fields and that our price is invalid. I'll provide some values again, but this time I'll make a price bigger than $1,000. And now we see that custom message we had based on that range attribute. Pretty slick. And if I change the price to $99 and hit Create, the save works and we're back at the listing. I'll guess that you may be wondering how you can find out more about the different options like range and custom messages and the like. Well, the README in the project has a link regarding validation and data annotations. So let's have a very quick look. Here's the page, and if you scroll down just a bit, you'll see a section for built-in attributes. There's quite a handful of options here, and they can make life quite a bit easier. Exploring these and experimenting with them is something I'll leave to you. Up next, we'll spend some time getting more familiar with views and how to make this app look the way we want. Now that our admin app is starting to come together from a functionality perspective, it's time to start working on some of the user interface, or UI, and that means we need to get a little deeper understanding of views and how they work. We'll be doing some UI work in this module, but the focus isn't on HTML, CSS, or any of those types of concerns. Rather, we'll be focusing on where you might apply some different changes to create the user interface that you want. Let's get started. There are 3 key view files that we've looked very briefly at, and now it's time to solidify our understanding of them. The first is the view imports file. This is a file that contains some namespace imports and tag helper references. You can use this file to simplify some of the code that shows up on individual view files. Next is the view start file, and generally this file simply specifies what layout you want to use. Finally, the layout file is a content file that defines what you might consider the shell for your UI. It should have the header and the footer for your app, the navbar that you might put on the top or the left side of your app, or even both. It also will have CSS and JavaScript references that you want included on every page. It'll also have a line to render the body content, and this is where the individual views get rendered. One additional thing to note is that the default layout view that was created with our project template includes a CSS file that only applies to it, something called CSS isolation. That applies to views in general, and we'll see it in a sec. Finally, each of these 3 special files can exist in view subdirectories, so if you wanted a custom layout or some using statements that only applied to a certain folder, you could put a version of these files in those folders and make them what you want. Let's see a little of this in action now.